Hello everyone, Victor here. In this video, I'm going to talk about another type of the conics, which is ellipse. Now, ellipse is slightly more complicated than parabola because, as you can see, it has more components, but it's actually not that difficult to understand. So, let's first begin with a couple of properties of an ellipse. So first we have what we call the center of the ellipse, and again we denote it as the x0, the coordinate of that as x0 and y0, and the center of the ellipse is located at here. Right? So basically, if you fold the ellipse by half and then again by half, the cross section of those two folds will be the center. All right, so this is x0 and y0. Alright. The next one is the foci. So in an ellipse, it has two focus points, and of course they are symmetric on two sides. So here I introduce another variable called c to you, and this c is simply a distance from the center to the foci point. So here, if we go back to the graph, it is actually this distance c, right? So this is the first foci point, this is the second foci point, right? And again, this is of distance c. All right. The next one is the semi-major axis. We call it a, which is actually a distance from the center, the longest distance from the center to the ellipse. So it is on both sides of the ellipse. This one is one of them. This is the other one. So because I said it is of distance a, so the distance is like this. So this is distance a, and the other side is also distance a. Alright. The next property is the semi-minor axis. We call it b, and it is similar to a, but it is actually the shortest distance from the center to the end of the ellipse, or to the ellipse. So it is here. So this is distance b, this is again distance b. Alright, so you have a, b, and c, which are just distances somehow related to an ellipse. Now the third one, again, is c, is the value c. We call it semi-focal separation, and interestingly, this value c has can be computed if you know a and b already. So the equation is given here, which is square root of a square minus b square. And another property of an ellipse is the eccentricity of the ellipse, which is given by the Greek alphabet epsilon. And you can get the value of the eccentricity by having a and c, and and divide a by c. All right. It is actually a measurement of how stretched the ellipse is. So basically, the more elongated the ellipse, the value of the eccentricity will be closer to 1. Okay, so last but not least, that is the directrix of the ellipse and it is actually another measurement of a distance, and this distance is from the center of the ellipse, which is here, and then all the way to here, and it is given by the formula a divided by epsilon. So if you substitute back using the definition of eccentricity, you have the a square over c as well, which will be useful when you are trying to solve some of the problems in the problem set. Alright, so in ellipse, it is quite similar to the parabola. So you have, but then of course you have more variables, a, b, and c. Once again, since a, b, and c are just measurement of distances related to an ellipse, they are always positive. But there are also two constraints for the values a, b, and c. First of all, the value a is always greater than b. Okay, that's why we call this the major, and this is the minor. And also the value of a is always greater than c, because the foci will always be inside the ellipse but not outside. Alright, now because of that, so you will see the equation of an ellipse something like this. Now once again, this is from the textbook, and this is the simple form, with the assumption that the center of the ellipse is at the origin. So from now on, we will be using the more general form of the equation, which consider that the the center of the ellipse might not be at the origin, so which is denoted by x0 and y0. Now, because we have two general forms of the ellipse, one is the landscape mode, like this, and so we have this formula. Right? This formula is this one. If we see an ellipse looking like this, which is in a portrait mode, there is a slight difference. The slight difference is, instead of having a as the denominator for the x part, we have b squared, and then instead of b, we have a squared for the denominator for the y part. So it's simply a swapping of a and b, and you have the general equation of this particular type of ellipse. So make sure that you know which particular general form of the ellipse that you will be using. Let's take a look at one example. So here, this one, the question is to find the equation of the ellipse with foci at 0,2 and 4,2 with eccentricity 1/2. So to begin with, let's roughly sketch out how this ellipse will look like. So first of all, we have the x and y axis, and then so we know that one of the foci point is at 0,2. So say this is 2. So we have one of the foci point here, right? And the other one is 4,2. So let's say it is here. So this is 4. So this is the second focus point. Alright, so from here we know that the ellipse will look like this in the landscape form. Alright, and with the major axis like this. Okay, and because of that, we know that we are going to use the general form like this, with a on the x side and b on the y side. Right, so the question now becomes, what is a, what is b, and what is x0, and what is y0? So you are going to figure out 4 variables for this equation. Now remember that x0 and y0 is just the center of the ellipse, so we know that x0, y0 should lie here, right? Now, so it is pretty obvious that we can find the center. The center x0, y0 is, first of all, we almost immediately we know that the y coordinate for the center will be the same as the 2 foci points, right? So we know that it is 2. And we know that the center is simply the in between these 2 foci points. So it is just 0 plus 4 divided by 2, which gives us 2. So we know that the center is 2 and 2, which is this point. Right? Let's write 2, 2 here. So from now on, we know this one, we know this one. So the next thing is to find a and b, of course. And how are we going to do that? Now let's take a look at the sketch again. Now remember that the measurement c of an ellipse is simply the distance between the center and the one of the foci points, right? So if it is 2, 2 and this is 4, 2, then we know that c equals to 2, right? So I'll just write it here. C is the distance between between the center and one of the foci points. So which is equals to, say, this 4 minus 2 equals to 2, right? Now in the question it already gives us the eccentricity as 1 over 2. So we have the epsilon equals to, remember the definition, C over A, right? And we have C already. C is 2. So this is A, and given that it is half, so it tells us that E equals to 4. Alright? Now we now have C, we now have A as well. So remember that the definition of C again is C equals to square root of A square minus B square. So which gives us C is 2, right? And equals to square root of A square. A is 4, so it is 16, right, minus B square. Then of course it gives us B square equals to 12, right? And because of that we have A, B and C all together, and the equation would be x minus 2 and over A square, which is 16, plus y minus 2 again, which is the y coordinate of the center, and we have B square as 12 and equals to 1. So there we have the equation of this ellipse. Now let's take a look at a more complicated example, which is taken from the problem set question number 2. So in the question again we are going to find the ellipse with foci points at 3, minus 2, 3, 4, and having a directrix 5 units from its center. Alright, so before anything else, let's try to sketch out how the ellipse will look like. So once again we have the x and y axis. This is the origin. Now from here we know that the foci point will be 3 minus, one of the points will be 3 minus 2, so let's say this is 3. So at minus 2 it is, say, somewhere here, right? So this is one of the foci points, and we're 3 and 4, so let's say it is somewhere here, right? So let's say this is 4. Okay, so from here we know that this ellipse will be in a portrait form, so it will be something like this. Okay, it will look something like that. Alright, now it also tells us that the directrix is 5 units from the center, so we have a directrix somewhere here, we have a directrix somewhere here. Okay, so because we know that the ellipse will be in portrait mode, we have a slightly different equation to use. Once again, it is just a swapping between A square and B square. Alright, so let's begin. Now first of all, we would like to find the center of the ellipse, that is the coordinates x and y naught. So the way to find it is similar to the first example. So we have the center equals to something. Now we know that the x coordinate of the center already. Why? Because it lies on the same line as the foci point. So we have the x coordinate 3. Now for the y coordinate, we just need to find the center, like the middle point between these 2 points, the 2 foci points, which can be found using we add the 2 coordinates together and divided by 2. So we have 3 and then we have 1. Alright, so here it will be roughly here. This is the center of the ellipse. Okay, so the next thing is so we have x naught and y naught, so let's try to figure out b square and a square. Okay, so to find that, So let's start with finding C. So we know that C is simply just a distance from the center to one of the foci points, right? So we have C equals to distance from center to a focus point, right? So it can be given by, say it is absolute value of 1 minus 2. So gives us 3. Okay, so we have C right now. Now from here, let's take a look at what else does the question give us. So it tells us that it has a directrix 5 units from its center. Now, if you refer back to the first slide, you will notice that there's a relationship between the C distance with the so-called eccentricity. So what we have here is the distance from center to directrix is equal to A over epsilon, right? Which of course is A squared over C, which is the definition of epsilon. We just substitute the value, the ratio C over A into this, all right? And therefore we have 5, which is the directrix 5 units from the center, equals to A squared over C, right? So from here we know that C is 3, so that's why we know that therefore A squared equals to 5 times C, which is 15. All right, we have A squared. Now the rest is of course to find what B squared is. So once again we have the relationship between C, A, and B given by this. C equals to square root A squared minus B squared. So which tells us that 3 equals to square root of 15 minus B squared. Alright, and then we have B squared equals to 6. Alright, so right now we have B squared as well, and because of that we can arrive at the solution of this problem, which is x minus the x coordinate of the center, which is 3 squared over B squared, which is 6, right? And plus y minus the y coordinate of the center, which is 1 squared over A squared. A squared is 15 and equals to 1. Alright, so we have the solution of this problem set, this problem. So once again, if you look back, it is the steps for finding equation of ellipse is, first of all, try to at least know that like how roughly the ellipse will look like, and then you figure out what type of equation that you are going to use. So either it is this, or like the A square and B square is swapped, and then you begin with finding the center, and by finding the center you find x0 and y0. And then from the other clues from the question, you will be able to find either C, the epsilon, and then using the relationships between C, epsilon, A's and B's, then you will be able to find A square and B square. Alright, and from there you will be able to figure out exactly the equation of the ellipse. I hope this helps, and I'll see you next time.